Alright, so let's go through the concept of refraction. So what is refraction? Refraction is the bending of light when the light travels from one medium to another medium of different denseness due to the change in speed of light. So first thing first, in light, right, we learn that the light travels in straight line. But that is only for when the light is in the same medium. So if example, let's just say I have a light, but this light travels from one medium to another medium, there should be some bending of light. Okay, so looking at the diagram number 1 right here, so notice one thing is that when the light hits the medium 1 and medium 2 boundary, right, the light actually bend away from the normal. So what can I conclude about the speed of light in medium 1 and medium 2 respectively? In medium 1, the speed of light should be smaller. When you go into the medium 2, right, you bend away from normal, so means that the speed of light should be faster. So in this case, maybe I can say, oh, medium 1 is glass, medium 2 is air. Because glass is more dense than air, so that's why in glass, right, the speed of light is lower. In air, the speed of light is faster. Right? Okay, looking at diagram number 2. So same thing, we have a light hitting on medium 1, 2 boundary. So but the difference between diagram 2 and diagram 1 now is that the speed of light bend, the light bend towards the normal. So I can safely say that the light slows down. Whereas in medium 1, right, the speed of light is faster. So I can say, the medium 1 might be air, medium 2 is glass. Alright, yeah, so that is the meaning of refraction. As long as there is a change of, there's a so-called the change in speed of light, there should be some bending. Okay. So what are some of the cases where there is no refraction, even though you are traveling from one medium to another medium? So for example, looking at the first diagram, so from air to glass, you notice one thing is that the light never bend, although I travel from air, which is roughly the refractive index of air is roughly 1, whereas for glass is roughly 1.5, right? So this is because the light enters perpendicularly into the glass. So in this particular context, there shouldn't be any refraction. And another thing to take note is that what is the angle of incidence of the light? So it's actually 0. Okay, so when your angle of incidence is 0, there shouldn't be any refraction. So for this is angle of incidence is equal to 0. Okay, looking at number 2, which is a semicircular glass block. Okay, I just want you to focus your attention on this part. P. Okay, the light enters the semicircular glass block at perpendicularly, so there shouldn't be any bending. Alright, so how do I know it enters perpendicularly? First of all, there's 2 ways to seeing it. First way, we have to use a bit of eye. So when the light enters, you can see that it's actually perpendicularly. Second of all, you can see that the light actually hits the center of the circle. So this, due to geometry, right, we can actually say that the light enters perpendicularly. So that is another way of seeing it. Okay, the third diagram will be so-called a triangular prism. So of course, this is 90 degree. So when the light enters perpendicularly to the surface, there shouldn't be any bending. Okay, last but not least, we have a full circle. Yeah, so when the light enters, right, so at this particular part, it is perpendicular. So when you enter the so-called the circle, you must cut through the center of the circle. So this is how I know it's perpendicular to the surface. Okay, alright. So of course, the next part will be the refraction index or refractive index of the materials. So the refractive index of material tells us how optically dense the material is. So for example, we have vacuum. Vacuum is about 1. Air is about 1 also, just that it's slightly above vacuum. So water is 1.33, ice 1.31, glass 1.5, and diamond is 2.42. Okay, so what is the definition of your refractive index? Refractive index is actually a ratio. of a medium, right, is the ratio of the speed of light in vacuum to the speed of light in the particular medium. So so just take note of this, is that the refractive index is not the ratio of the speed of light in air. So this is wrong. We must say that, oh, it's the speed of light in vacuum to the speed of light in the medium. Okay, so the next thing is, how do we calculate the refractive index of a particular medium? So first thing, there is two formula. So the very first formula will be n equal to sine I over sine R. So n is the refractive index, right? There shouldn't be any units. So no units means this is not a physical quantity. Remember what is physical quantity, right? Physical quantity means there must be two things. First, must have a magnitude. Second, there must be a unit. So since ratio, there's no unit, so it's not a physical quantity. Okay, of course, the next thing is, what is the angle of incidence? Okay, angle of incidence, just take note, is always in the less dense medium. The angle of refraction is always in the more dense medium. That is the first formula to calculate your refractive index. Okay, the second formula is regarding speed. So if you are given speed, you can also use the speed to calculate. So n equal to refractive index equal to c divided by v. What is c? C is actually a constant. So this constant is a must to know. What is the constant? It's the speed of light in vacuum. So this is so-called the maximum speed in the universe. So you cannot exceed this speed. If you exceed this speed, means you are breaking the laws of physics. So the speed of light in vacuum is 3 multiplied by 10 to the power of 8 meter per second. So what is V? V is the speed of light in the particular medium. So for example, let's just say, I'm talking about glass. So the speed of light in glass is, for example, is 2 multiplied by 10 to the power of 8 meter per second. So if I want to calculate the refractive index, you can actually get 3 divided by 2. I mean the whole thing, when you divide, you should get about 1.5. So that is how we calculate the refractive index. Okay, so let's take a look at case 1, where we have this less dense to denser medium. So you can pause this video to try this question yourself first. After you try this question yourself, so you can replay this. I mean, you can just continue the video and I'll go through this question together with you. Okay, so let's go through this case number 1, where we have this light. This light is it's traveling in the air, then after that enter the glass block. Okay, so let's take a look at what the question wants. So when light from air hits the glass block at an angle of 60 degrees. So this is actually our angle of incidence. So it refracts towards the normal with an angle of refraction 40 degrees. So determine the refractive index of the glass block. Okay, one thing, let's look at what we are given. We are given the angle. So if we are given an angle, we must use the first equation or the first formula. So first formula is n equal to sine I over sine R. So my I is in 60 degree, my R is in 40 degree. So if you calculate, you should get C. So you should get roughly 1.347 or 1.35. So that is the refractive index of the glass block. Okay, for part B, assuming the speed of light in air is 3 times 10 to the power of 8 meter per second, determine the speed of light in the glass block. So we need to use the part A answer to help us calculate the part B answer. So of course, let's write down N equal to C divided by V. So what is C? What is your C? C is actually the speed of light in the vacuum. So this one sometimes they will give lah. Of course, it's good to know just in case that they don't give. Right? So N is equal to 1.35. So next, let's calculate what is our speed of light in the glass block. So 3 times 10 to the power of 8 divided by 1.35. So we should get roughly 2.22 multiplied by 10 to the power of 8 meter per second. So that is the speed of light in the glass block. Okay, so that's for case number 1. Okay, let's take a look at case number 2. So same thing, you try the question first, then after that you can pause the video right now, then you continue to watch this video. Okay, so we have this case 2 where we have this semicircular glass block. So first of all, determine what is the refractive index of the plastic, and part B, of course, the speed of light in the plastic. Okay, we are given a few things. So we are given an angle, so we must make use of the angle formula, n equal to sine I over sine r. So let's look at our thing. So we have these 28, 62, right? So first thing we must really see which one is the angle that we are interested in. We are always interested in the angle between the light and, of course, the normal. Yeah, all right. So we are interested in the 28 degree. Okay, so let's write down 28 degree first. Okay, then next is we are interested in this 42, right? Okay, so 42. Okay, after that, let's apply the refractive index formula, right? So n equal to sine I over sine r. So if you apply sine I over sine r, right? So I and r is right here. So let's put in 28 here. Let's put in 42 here. Okay, so let's write down sine 28 divided by sine 42. Okay, so one thing you notice, if you use this thing, if you use this idea, you will get roughly 0.702. So apparently it's less than 1. So your refractive index cannot be less than 1. So this is a wrong answer. So what is the issue in this particular case is that, okay, we need to understand one thing is that the angle of incidence is always in the less dense medium. So of course, this 42 is what we call the angle of incidence. Then this 28 is what we call the angle of refraction. Yeah, of course I understand one thing is that my light is incident at this particular portion, right? So 28 by right should be my angle of incidence. But in physics, right, in physics is a bit different. So in physics, we must always take note one thing is that the angle of incidence must always be in the less dense medium. Then after that, the angle of refraction must be in the more dense medium. So this is always in more dense medium. Then after, angle of incidence is always in less dense medium, irregardless of how the light travel. Okay, so let's calculate the refractive index of the plastic. So A is equal to N equal to sine I over sine r. Okay, what is I? I here is 42. Then after that, R is 28 degree. So sine 42 divided by sine 28. So you should get roughly 1.43. So okay, let's calculate let's do the part B. Okay, part B is the speed of light in the plastic. So part B is N equal to C over V. So what is C? C is 3 times 10 to the power of 8. V, I don't know, I want to calculate. So N is 1.43. So 3 times 10 divided by 1.43. So you should get roughly a speed of light in the plastic is roughly 2.10 multiplied by 10 to the power of 8 meter per second. So that is how we do case number 2. Okay, alright, so just take note of all the different calculation thing, right? Okay, let's I'll pause here, then after I'll go through all the different checkpoints in other videos.